Hi everyone, this is Priyanka and today we'll learn how to solve a transportation problem using Solver in Excel. So the problem you're seeing on your screen is the one that we'll be solutioning today, and what this basically says is that we have three factory locations in Dhaka, Kathmandu and Colombo. Each can produce a capacity of 200, 600 and 600 units each, and then we have three stores, one each in Mumbai, Chennai and Bangalore, and the demand to be fulfilled at each of these stores is 600, 400 and 400 units each. What you're seeing in the grid, which is the 10, 8, 6, 16, 8, 6 and the 18, 14 and 10 are the per unit transportation costs to transport one unit from each factory location to each city where we have our stores, and we basically need to find out how many units should be transported from each factory to each store location in a way that the transportation cost is minimized. The first thing that we're
to do is you are going to copy this grid and you're going to paste it right here. Okay. Now, what this grid here represents is your unit costs for transporting things from these cities to these cities right here. Now, the matrix right here, the one which we've just pasted, is the matrix where you will be deriving your solution. So in this matrix, these 9 columns are going to tell you the number of units that you'll be transferring from each of these cities to each of these cities. So these are your per unit costs, and this matrix is going to denote your volumes. So let's make this very clear. This matrix is for costs, this matrix is for volumes. Now, when you end up solving your problem, and you'll know that, for example, 100 units will be transported from Dhaka to Mumbai, 50 units from Dhaka to Chennai, 50 more from Dhaka to Bangalore, or whatever the solution is. Once you know how many units you'll transfer from each city to each city, you will have to multiply each of those units with the corresponding costs. And when you add up these costs, you will have the total cost of transportation that you'll be incurring, right? So the problem that you're solving is for your total transportation cost. So we'll just type that over here. And the way we derive the total transportation cost is multiplying this grid with this grid. So the formula in Excel to be able to do that is called a sum product. So you just type the sum product formula. You select this grid right here, and you select this grid right here. So what Excel will do is it will multiply all of the values here with all of the values over here to give you your total transportation cost in this cell right here, which is cell C22. Now, the next thing we need to do is we are going to move this column to the right, and we are going to move this row one row below. Now, we call this a store demand, and your actual factory supply. Now, just give me a second to format this. I have a bit of OCD, so unless and until my columns are all neat and clean and properly highlighted, I'm not going to be at peace. Please give me a second while I do this. I just need things to be very organized, otherwise it doesn't quite work for me. Okay. Now let me tell you why we are doing this. Why did we add the additional row and the additional column? Okay, now the reason we've added this column right here and this row right here is because after we find the solution to the problem, Uh, these columns are going to tell you the actual supply that each of these factories is going to be producing. And this row is going to be telling you how much demand, the actual demand for each of these cities will get fulfilled. Okay, so basically, this is the maximum capacity each of these factories can produce. This is the actual capacity or the actual units that they'll end up producing. This is the demand that is required to be fulfilled, and this row will tell you how much demand actually gets fulfilled. Okay, that's why we added this additional column and this additional row here. I don't know how those zeros got here, so I'm just going to delete them. Now we move to the actual solutioning of this problem, which is solving the transportation problem using Solver. Now the Solver add-in is an add-in that you'll find on your data tab here in Excel. So what you're seeing right here is the Solver. So many of you, when you go to your Excel, you'll not find the Solver option here. So I'm going to show you how you can get that on your ribbon right here. So in order to get the Solver option, what you do is you go to File, you then go to Options, you go to Add-ins, you will see this drop down here. So you're going to pick Excel add-ins and you hit Go. Now, because I already have the Solver installed here, you can see that this option is already checked. But for those of you who do not have Solver, this option will be unchecked. So what you'll do is you'll just go ahead and check it and you'll say OK. So then Excel will take a few seconds and then it's going to pop up the Solver option right here on your ribbon, and then you'll be ready to use it. So that's how you install it. Now let's go ahead and solution this problem using the Solver. So I'm going to tell you what you need to do on this screen right here. Now, this box here is called set objective. What you put in this box is the location of the cell where you want your transportation cost to be displayed. So we're trying to compute the minimum transportation cost for this problem, and we want that number to be displayed in this cell right here, which is C22. So I just picked C22, so it's appearing over here right now. So what we're trying to do in this problem is minimize the transportation cost. So this is a minimization problem. So you pick the minimize option here. By changing the variable cells, so the solution that you want is going to be in these cells right here. Okay, this is where you want your solution. So you pick these cells. These are the ones you want to change, okay? Now this space here is for your constraints. Now if you ever solved a linear programming problem using pen and paper, you're going to write down, you write down a set of constraints. It's a set of equations that outlines the limitations that your problem is subject to. So this is nothing but a space for you to add those. So hit add. Now your very first constraint, let's start with the horizontal ones first, okay? So you need that your actual factory supply, it should be less than or equal to 200. That's because the Dhaka location cannot produce more than 200 units. That's a limitation. So you're going to say that this cell is less than or equal to this cell right here. That's your first constraint. Similar constraint for Kathmandu. And similar constraint for Colombo. Okay, now we go to these constraints right here, okay? One thing to keep in mind is this is a demand, so it has to be met anyhow. So we do not pick the less than or equal to option here, we pick the equal to option here, okay? So you're going to say first that cell C19, which is demand for Mumbai. I'm sorry about that. The demand for Mumbai is equal to this cell, which is 600, meaning Mumbai should get 600 units anyhow. So less than or equal to is not an option. Mumbai cannot get 520 or 580 units. It has to get 600. Okay, so we don't do less than or equal to here. We do equal to. Chennai is equal to 400. So just select the cells. Don't hard code or don't type in 400 over here, okay? And Mangalore is also equal to 400. And add. You're done with your constraints now, okay? Just hit cancel, so it'll bring you back to your original screen. Just make sure that you have your constraints right. So we have C19 is equal to C20, meaning the demand must be met. We have D19 should be equal to D20, and we have E19, which should be equal to E20, which is your first three constraints. And the next three constraints are F16 should be less than or equal to G16, F17 should be less than or equal to G17, F18 should be less than or equal to G18. So you have these 6 constraints. You are going to use simplex linear programming to solve the problem. So just pick that option and then you hit solve. Solver has found a solution. Your solver has now found a solution for you, which is 15,600. Now, let us try to read this solution. What the solution means is that you should be transferring or transporting 200 units from Dhaka to Mumbai and no units from Dhaka to Chennai and Bangalore. And that's because the Dhaka factory's capacity is maxed out. Its maximum capacity is 200. It's already transporting 200 units to Mumbai. It cannot produce any more. For Kathmandu, the Kathmandu factory should transport 400 units to Chennai and 200 to Bangalore, and the Colombo factory should transport 400 units to Mumbai and 200 units to Bangalore. When this happens, all of the demand in all of these 3 cities, Mumbai, Chennai, and Bangalore, will be met. As you can see, they need 600, 400, and 400 units, and all of these 3 demands are being met here. And we're also utilizing the full capacity of all of the 3 factories here. The total cost in order to transport these number of units from these locations to these locations is 15,600 rupees or $15,600 or whatever your currency is. And this is the least possible transportation cost that you could incur. If you try any other kind of combination in terms of sending certain number of units from these factories to these locations, then the cost for any other combination will definitely be higher than 15,600. When we use Solver to solve this problem, it gives us the least possible cost. Now, if you want to try or test this out, we can actually go ahead and do that. So let us change this combination a little, okay? So instead of 400 units all in Chennai, let's do 200 in Mumbai and 200 to Chennai, and you'll see that the cost will go up. It'll go higher than 15,600. So I'm going to get rid of the 400 from here, and I'm going to split it into 200 and 200. Look, it's 17,200, right? Let's go back to the original solution, okay? Try any other combination. Instead of 200 here, split it into 100 and 100, okay? So I'm just going to do 100 and 100. Cost is higher than 15,600. Try any combination and the cost will definitely be higher than 15,600, okay? So the least cost you could possibly incur while still satisfying all of the demand at all of these stores is 15,600. So we've solved the problem, and this is how you solve transportation problems using Solver in Excel.